So, good morning or evening, depending on the time zone you are in. Thank you for joining us today for this Forge API update session. As I said, it's very nice to see such a big crowd. So Augusto and I are very happy to be with you tonight, or morning for you, to kick off this Forge Dev Day online. And we will focus with a talk about data. Autodesk has been talking a lot about data at the center, so we will try to explain what it means into the Forge API coming this year. So data is an incredibly exciting topic. And the reason is that when you start talking about data as a common data environment or place for storing your information, the reason is that this topic is very exciting, that a lot of people really care about data, and that includes many of you. So Autodesk will try to solve some of the problems you may have, but not all. So you need to understand where we are going to with data at the center, on how you could help us to figure out what is really important for your industry or specific needs. So we'll try to describe that during that session, as well as giving you update on the existing API which already exist. So first, an exciting safe abort paragraph that I assume everyone knows, so I won't spend the time to read it, but there may be things I'm going to say in the first part of this presentation which only reflects our intent about developing data at the center. So as I said, with me today we have Augusto, which is also a developer advocate working with me at Autodesk. So he's very knowledgeable on many technologies that Forge is exposing, as well as other software like Navisworks, InfraWorks on Revit. So we'll see that. And this is what we're going to cover. So first, the Forge Data Platform, what it means, on how it's going to work, or how we are developing it. Some API which will come with that, which is about how you can automate different tasks, and automate different operation on Forge without too much coding like you do today. And then we'll briefly talk about different API updates which will be introduced later during these Dev Days online, so such as the Design Automation API, the BIM 360 on the viewer, on few things which have changed recently that you really need to pay attention to avoid any mistake. And then we'll see if there is any other Q&A session we need to run, depending on how we did during this session. So over than 30 years, Autodesk has developed a good amount of API for different industry, so AEC, manufacturing, and M&E. So you could use Revit to design buildings. You could use Maya to do games on film, Inventor to design car, as well as Alias, etc. So, but what is really important is each of these products has been fairly successful in its own market. But the big challenge here is, how do you share IP or design intent between different products? So you may design a manufacturing asset that you want to use in Revit. So the data interoperability and data exchange between these software were not very easy, even though they were Autodesk products. So each of these data is locked in a product and tightly coupled to the product who designs this data. So we'll see how we're going to try to solve this problem. And here I took two examples with Autodesk software, but you can imagine how hard it would be with other products like SolidWorks, Solid Edge, CATIA, or Rhino, when you want to get this information to one of the Autodesk product or another. So during this talk, I know I'm going to spend most of my time on the Revit side. I apologize for that, but the best example I have are coming from the construction side. So I'm going to use Revit as an example, but that applies across all products and not only Autodesk products. So I'll give a couple of examples here. So to come back to what I said as an intro about what Data at the Center is about is, if we consider Revit, Revit is a software who design your ideas, so your design intent, and it's very high level and very traditional architecture stack. So you have different presentation layer with UI and interaction. You have a specific business logic that belongs to Revit. So you can create your buildings. And then, but it's very generic architecture stack by means that you can only do what Revit allows you to do, and you can model only what Revit can support. So there are things that Revit doesn't do well, and you may need another software to do that. So on sometimes you need collaboration. So we can separate these three layers into the presentation stack, the business logic stack, on the data. If you apply that logic, so this is how Revit would design, for example, the bridge. If you apply that same idea to other software, you have exactly the same thing. So presentation, business logic, and data. On each of them would store the information in a specific manner. So if you look at AutoCAD Inventor, even Fusion, which is an online version of Inventor, then each of them have a similar story, but they also have persistence data which are proprietary to that software. So how do you unlock the data so you can use in different business logic or across design intent? So if we take again the example of how we did segment the construction market, we came with this nice design where every different steps follow each one, and one after each. But actually, you can use software in each of these segments to do piece of the work. On here, you're already challenged by how do I exchange information between software in a very organized and nice design workflow. But what about this? Because we made that nice picture before, but it's more like today, does every steps follow each other? Usually not. So the data is really mangled into a huge database, I would say, for now, on how can you collaborate between the different people, software, and keep that data relevant to reflect what really exists or reflect your design intent depending which stage you are. So it's not a waterfall process anymore. It's not linear, but you can have a more complex scenarios that a single application can handle. So you always have to work with different sets. Solving that issue at once would be very difficult. And this is not what we're going to do because we don't have the ultimate answer. But instead, we're going to work on minimum data necessary for given industry workflow. And I have two examples. So one from CW Killer, which was about how you can work with different software to design a building using different industry, but still collaborate. On here in this example, when they want to build this wood design wall, the only important point is where this wood wall would be attached into the building, nothing else. There's no other interaction. So we could agree, and we would call that a contract, that the architect on the wood wall manufacturer can agree on the only important piece are the size for sure of the model, but the attach point. So if they can agree on this attach point as being the relevant data they need to exchange between the two software, so they can collaborate and they can import each other the relevant information later, then we solve that workflow in that specific case. For sure, this is a very minimum example where we only need a couple of attach points, but you understand the principle is instead of sharing the whole building with this wood manufacturer, we only share the space he needs on the attach point. And that's enough for him to continue his work. Another example is the San Francisco Mona Museum, where in 90% of the building could be designed in a traditional process. And on the facade, need a special process because it's made with another set of tools. On the manufacturing of that facade as well is very different. So again, how do you process each of the model? I would say one is a Revit model and the other one is something else, and still collaborate for the design of the complete construction. So not only the design intent, but as well as the operation, the construction, and so on. So for that, you need to agree on how the data would transit from one side to the other. So each of the contributors to the project agrees on how they work, on how they deliver each of their piece to design this museum. And here, it was a more complex operation because there was iteration. So this is where not only you need to agree on how data are exchanged between software and people, but because there are iterations, how you can keep this workflow of data coming in and have the project moving on without being broken anywhere. So these two things are really important to understand the what we're trying to address. So the first thing we want to do is there is walls between each of the software, and this wall can be broken very easily. So instead of trying to, like in the past, Autodesk did try to export the whole data from one software to another with mixed success. Sometimes it was good, but most of the time not. We'll see what are the fundamentally similar operations that needs to be covered by each of the software, on how we can make the flow of the data easily between these software. So how do we break these walls and make sure that the data keep consistent between iterations? So it would be point-to-point connections. If we try a direct approach. And that's where the Forge derivative service and translation service become useful. So you can export one model entirely and start using that data so you can transform it in a simple workflow into a different database or format that you can use into into your application or business logic. But there are several limitations with this approach, and I'll mention a few. So this architecture doesn't tell us where the data goes. It doesn't give us a data persistence mechanism that is independent from any individual tools. This is a point-to-point architecture lacks something in the middle. It also makes it necessary to support N²2 connections between apps, so exchanging, for example, from Inventor to Navisworks as well as Revit and so on, which is hard to maintain between software. In some cases, you may lose information as a result of translation back and forth. In some cases, you can't follow this workflow as smoothly you would like to, because translation takes a lot of time. So one of the things with model derivative that people complain is that you post a file and then you translate, and that takes time. It may be a couple of seconds to many minutes. So this is something which you can't really solve with that scenario. In some cases, you translate the data, but it's impossible for you to know the logical object in one of the formats into which comes from another software. So all these limitations that we are fully aware, we'll try to break them into minimum fundamentally different look at the data. So let's take a couple of assertions about what we want. So I want to see my data in multiple Autodesk applications. And I want to use, in this example I gave, my data from Revit into Excel, but not only one way. It should be a workflow. So I want to be able to export, let's say export or use my data into Excel. And once I do some modification in Excel, I want this data to come back into Revit. So it's a bidirectional scenario this time, if I compare to model derivative, which is a one-way export. So that's the first assertion. I want to see that data in multiple applications in one place. So we're talking about collaboration. So every single application can use the same set of data and can collaborate on this data. I want to be able to add my own data that nobody else will delete. So that's about extending data. So really it's about how do I build a workflow with a contract between applications without breaking that contract if I had some specific information. And last but not least, I need the things I learned about design decision during pre-construction to carry through to construction and operation. So here we're talking about life cycle. So these are, I think, the main intent that we want to address with this new approach. So the last intent was really specific to AC, but you understand the principle that we want to address. So I come back to this slide where we have these walls between apps, and we can't break everything at once. So we'll start by breaking the data layer. And how can we expose all or an abstract of the data between software to solve, let's say, an industry standard workflow or something like that. So the next question is how we're going to do that. So that will be implemented on the Forge Data platform, and will come with a different way of working with the data compared to model derivative. And for sure, we will support more than Autodesk product to improve interoperability. So we also support different third-party application, and we'll see later how we can support this. So what is really important here is we will define into the Forge data platform as a collection, and what is important is the common data modeling and data management needs. Needs is a keyword here. So what do we want, what do we need, and what do we want to address from many different stakeholders with an initial focus on our own product. And these needs may vary between different people, different products, we understand that, but we will try to define, let's say, industry standard schema for people to exchange data. They could be extended for sure, but we will come with some common industry standard schema that most of the people use, and then people can elaborate from that. So in the benefit of unification, what does it mean? If we can break through this gray wall, then we will open interoperability, workflow, and we could ultimately have machine learning because we could grab data directly from the design intent file format. And then for you, it means that you can reuse, you can scale this information with less maintenance. So in the Forge data platform, we're putting together a unified architecture that addresses common data modeling and data management needs for your apps. That's really important to understand. This new architecture will be entirely designed for your apps. For our users, it improves interoperability and facilitates supporting increasingly complex workflow. And for me, this is probably the most important thing, workflow, which means not only you can automate different tasks by using different services like you do today, but in a more simple way, but you can also start thinking about lifecycle, because you can understand that the data can go from, let's say, one step to another, but it can come back. So you have this idea of the data flows two directions. And I know many of you are really interested by these different workflows. So remember, the architecture on the left reflects an application first, data second, which is about how you would exchange data from one software to another. And we're going with the Forge data platform with the data at the center. So something more close to this. And we form a common data environment where you happen to have a different experience. So you connect to the data, you consume to the data, and you contribute back to the data. So the data is really meant to be at the center, regardless of the applications that were used to create it or manipulate it later. So the data doesn't die, nor it stops making any sense. It's just evolving in your workflow. So for continuing the discussion, because I'm kind of done on the data at the center, now I'm switching more onto the workflow idea. I want to start with this slide where Autodesk, usually Autodesk presentation ends with this slide where make anything. But Autodesk has been really good in history about design, not make. So projects like AutoCAD, Revit, Inventor are very good at design intent, but often when it comes to getting that design made, we didn't thought about how to make these models available to other software or over the wall for someone else to figure out how to make part of the problem. So that's what we want to address as well. Design, make, uninstall. So that's what we'd like to address. So no one application or model can handle a full project lifecycle. No doubt on that. There's always multiple applications involved on any large project that introduce data interoperability challenge. And they are very inefficient, and they're usually very inefficient, and have even created unwanted job titles like data wrangler or data managers. What I would like to say here is it also introduces human errors if it's not fully automated. So that's really a complex thing. So even for small projects, you can see, as long as you start iterating, if you don't have processes in place, you make your work harder about translating data. You source of errors, and you're not spending your time where you should be spending your time. So that's what you need to address. So if we look at how things are done, usually in the industry, you have different system or phase, and each of them needs to interact with others, and you need to agree on how you're going to work. And in very complex scenario, you may have different phases running side by side or in parallel, and sometime later they would need to be merged. So how would you take care of that if you don't have a data at the center for mangling the data, but as well processes around to make sure that the information contained into these contracts allow you to interface between the different systems. So the other aspect to consider is the legal aspect. There is an actual disclaimer page in a Revit model from one of our major customers. They don't want others to use the digital model data directly because it is difficult to verify the level of specificity and completeness for the entire model. So that opens them to liability. So they're still scratching all the data model data down to to-do sheets. So they can control the flow and degree open information, and the sign-off is done still on paper. Anytime you scratch the digital information to paper, by definition, you're not going to have an automated digital workflow. So it's kind of frozen, and it can't really evolve without a different iteration, etc. What about if someone put annotation on these 2D sheets? How does it come back into your workflow? That's simply put like this, a not trusted environment to exchange digital information. So what we want to address is two major concepts. So the data contract, which is a template that defines a minimal exchange of data without sharing the full digital model. On the escrow, which is a term coming from the Quantum project, which was a research project here at Autodesk, which is specific repositories that support asynchronous workflow with an impartial broker in between to organize the communication between the different apps. So an escrow is a term borrowed from legal and financial transactions where you need an impartial broker to ensure that there is an accurate record on fair exchange between the data. So you can define your own data contract on escrow in this concept. So if we look at a simple way to see that is, you have a design, you go to fabrication, and you have someone installing it. And if you have a contract in between all these different steps, the data, the minimum data you need at each different steps, you could agree on how that would be shared between different operational people. So the data would be maintained, you can trust the source, and everyone can modify to a certain degree the information they have access to. So you can imagine, for example, when you're on the installation side, the guy installs, for example, something on the roof, and then you do laser scanning, or you have a bots running to verify that it was installed as designed, and the bot can send back the result of his investigation, so the architect can have the sign-off about it was built as designed. That's the idea. It's not something you can do today. In this example, this is actually a very simple view of the complex workflow CW killer organization built for the project I introduced before. What is interesting is this project was quite complex, but after having used it for that project, they started to use it for every project they develop now, and even for very simple projects. So they saw the value of implementing such workflow. So this is another example coming from Zahadid, a project made in Macau. And there is no way that you could make a design change here manually while you try to figure out all the ramifications. So Front Inc., another customer, had to automate the flow of information amongst all the different apps, services, and people who participated to this design. So each state of the process would transfer for some information, not all, and do a validation check to make sure there's no assumptions violating the contracts. And the change would kick off engineering calculation on report for each structural member of the facade, and would result in an automatic generation of more than 128,000 shop drawings. Without automation, you can't really achieve such a task in the limited time frame they had to achieve the project. So the value of an orchestrated workflow is really about saving cost, making sure that every step talks to the other steps, and have agreed beforehand on how the data transits from one to the other. So you're not losing information, you only work on the important information, and you don't corrupt your model. So just make your job more easy, so you can concentrate on really where you should be spending your time, rather than about how the data goes from one side to the other. So again, because people would probably ask a lot about what I've just introduced, this came from the original idea of the Quantum project. And we have looked at what the Quantum project achieved on how this could be put into the Forge API. So you may hear different names, UDP, which is Unified Data Platform. So that's an internal name. The API, which will come on Forge during this year, is more the Forge Data Platform. On that include the data at the center as well as the workflow and automation. So we did talk a bit about this API during AU, so I repeat it there. We'll be introducing some of these concepts during the coming year. And if you're interested to participate, if you're interested to collaborate with us, you're really welcome to contact me or Augusto in the next few weeks, months. So we understand from you as well what are your needs and how you can help us to design completely these new models. So few last words on workflow. And this is just to give you an idea how we think about implementing workflow. Again, this is to simplify coding on your side. So I'm not sure if you watch at the design automation API samples that Augusto, myself, and Zong created for AU back in November. But we had to implement our own webhook system and launch system for running different tasks. So that was done on a server, waiting a webhooks to call us back to launch another step. The workflow automation would address that. So there would be already pre-made bricks for different operations that you can assemble in a very simple way. So it could be point-to-point application workflow, microservices orchestration, some human participation, and I'll explain what I mean by human participation, or all the above. So you can really create complex workflow in a very simple manner, ideally without writing any code for the workflow automation part. So to do this, we will be separating layers in different things. So you have the application layers, the data plane layer, orchestration plane, and the microservices plane. And microservices could be your own services. So if someone wants to use one of your service that you host on your server, from the orchestration plane, it could use that API to launch something on your service and get the result back into the data plane. So just to explain what it is, so let's look at this example where we want to have a land surveyor to work with the architect, as well as doing some simulation for solar analysis. So the architect would design his building in Revit, and then today, if you want to work with a land surveyor to determine what is the right location for his building on the field, he would probably send the Revit model to this guy. But this guy works in AutoCAD most of the time, let's say, in this example. And he doesn't care about anything about the building except it's the footprint, right? The perimeter. So why sending him the complete model? Because the first thing he would need to do is just to extract this perimeter from Revit and put it in AutoCAD so he can work with his software on tools, and then send back the information to the architect. So that is workflow, and he's probably not an expert in Revit, so that would consume him a lot of time, subject to loss of information if the architect on the land survey has to do a workflow about iterations. At the same time, in parallel, you may want to launch some simulation for solar analysis. And here, you don't care about what is necessarily inside the building, but you're more interested by the materials on the facade, on the roof, but the inside you don't really care either. So what kind of information should be exchanged? If the architect do some change, you want to automate that task. Where for the first one, there is a human operation in between because that's a person. So you could design a workflow like this one, where using the API, you could launch different operations. On a different stage, because as human, you may have optional decision to make, which could sometimes be automated as well. So for example, let's say you send a mail with the relevant information to the land surveyor, and after 2 weeks, he hasn't responded. What's your decision? Do you send him another email to remind him and give him another week? Do you want to do something else? You can design that into your orchestrated workflow. As well as, if you want, you can use 2 different land surveyor and ask for a quote. So they say you can choose these people. So it's really about designing how you want to automate your workflow and treat the data here. And again, as I said, for the design automation example we wrote with Augusto, we had to do our own implementation, but really it's about how to simplify the implementation. And you can spend the time where you should be spending your time, where is a real value for you. Okay, so now design automation. So there is a version 3 of design automation coming. It's still in beta. And there will be a presentation tomorrow made by Augusto to explain you what the API is really about. So I won't spend too much time here to talk about that API, but version 3 would support AutoCAD, Inventor, Revit, and 3D Studio Max. There are a couple of limitations for each of these products that Augusto will review in details tomorrow. But yeah, so the presentation is tomorrow. You have the link here. If you haven't registered yet, you should be attending if you really want to run headless of these 4 products on the Forge API. BIM 360 API. So in the last year, we have introduced a content administration issues API on not only 1 version, but 2 versions. RFIs on checklist. The presentation would be made again through these DevDays online on March 5th by Mikako and Augusto. So again, if you're interested to hear about this API and what have changed or been introduced, I strongly encourage you to subscribe to this session to know more details. The Forge viewer. So there was a couple of change about the viewer along the year. So in theory, every month we have a new version coming. So right now, if I'm not mistaken, the latest version is version 6.4, where we did introduce Danish local support, undo for markups. On here, I would say this is a Forge markups, not the BIM 360 markup. So just be careful. They are different today. There was also a PDF change support made in the viewer, but it was made in a previous version of this one. So you'll see that in the next few slides. It's been changed there. And you have a geolocation extension as well. So now, if you were not aware, in the metadata coming with the SVF file, I mean the SVF bubble, the geolocation of your model was there, but there was no extension really making use of that. So now you have that extension available if you're interested. So before that version, there was the Autodesk Pdf extension, and that did follow actually a change made in a previous version about how we support PDF leaflet schema. So we were skipping zoom level, so I know that 1 or 2 people had issues with that. So use the latest version of the viewer if you have PDF issues, because one of the previous version of the FlowViewer had a change on the zoom level where it was not very well supported. So OMV extension for machine verification workflow was in version 6.2. 6.0 was a breaking compatibility version. That's why it's a major version. So one of the change which happened during the year is now we really do major version for breaking compatibility version, whereas the dot versions are more like incremental version, which was not the case before. We were for a long time on version 2 with breaking versions. So now the versioning schema has changed and is really consistent with industry standards. Okay, so for example, version 5, which I think was the only one for version 5, etc. So just to finish that presentation, and I hope I'm still in time, yes, there was 2 major change in the REST API in the last few months. So the first one, where I did contact you during summer, was about the TLS change. So we did enforce version 1.2 for security reason. So there was a blog article about that change. By now, if you don't have TLS 1.2 on your API, you would know, because starting October 31st, we started rejecting any REST call without TLS 1.2 support. The other one, which is more recent, is the content length header enforcement. So starting March 1st, which is Friday, if I'm not mistaken, we would enforce content length header for put on post REST call. Most of the SDK and REST client had this header automatically. So in theory, if you're using, let's say, industry standard tools or libraries, you would not care too much. But if you get a 400 error code in return of a call for a put on post where it was working before, it's most likely that, let's say, your library or your SDK did not have the content length header. So please review your code to make sure that you have this content length header present. Otherwise, March 1st, you may see some 400 error code coming back. I did publish an article on this on our blog, and I did contact each of you who had not the content length header in his REST API call last month. So if you haven't heard about me, you can guess you're safe. Otherwise, please work on fixing either your library or your code. And with that, I think we can open the floor for questions. So I don't know if there was any question. So I see there was 23 questions
I
also.
have one question which I said I will ask you at the end.
Okay.
So one of the participants wanted to know about AR/VR kit.
Oh, the AR/VR toolkit. Okay, so thank you for asking, Viro. So it's still in research mode, research project. So we have 2 servers. Well, I mean, we have more than 2 servers. We have 2 different versions of the server. So we have what I call the legacy server today, which is the one by default, which use the previous, let's say, API and mechanisms to prepare the scene. And we have a beta server, which we are testing right now. So if you're interested to test this new server, which is faster and more reliable, you're really welcome to use it. It scales automatically, this one. So if we have high demand, the server will scale, and the Unity plugin we provided to use that server is also faster. So to give you an example, it's like between 17 and 20 times faster to bring your model into the Unity engine. I can't really say more today. If you did ask me the question in a week time, I could say more. But if you're interested to know if it will ever become a Forge public API and supported as such, just drop me an email within a week. I should have the answer.
One more question was, are we sharing the PPT? I have said normally yes, we do share as a PDF, but I said I'll check with you.
Yeah, we will, definitely.
Thank you.
And there was a question on the workflows. So he was asking, comparing the workflows you presented with the workflows inside Vault, which are used to approve documents.
Yeah, so in Vault, you approve documents. The Forge automation on workflow API is about automating tasks on data. So the difference is there. In the Forge workflow things, you could sign or approve a document if you want. There will be a break for that, for sure. But it's more about, for example, in one of the examples we wrote with design automation, it was when someone posts a file on BIM 360 docs, an inventor file, we automatically create a Revit family, and we do automatically browse the project for every single Revit file, which we're using that family to make an update into the Revit file. So the workflow API would be to address these kind of things. Or for example, whenever in the data at the center, someone modify data in one of the data contract. For example, let's say you want to you change the model of a door, and you want to automatically kick off another process to calculate, I don't know, the price of all doors in your building, on exporting it to Excel. That would be more this kind of workflow that we want to address through that API, rather than sign off of documentation. Okay. Do we have any other question pending?
No, not at present.
Okay, so did all the question could be read by everyone? I mean, in the Q&A thing, or was it? Yeah, I think.
No, I think it can be read by everyone.
Okay. but you would save these questions on answers.
Yes.
So okay, so we can publish that.
Yeah.
So in case you want to review again the questions on the answers that both Vero and Augusto gave, you'll have this posted by Vero as well.
Yeah, we will be sharing the recording as also the PPT in a couple of days' time.
Okay, so I'll send that to you probably tomorrow. Yeah.
Sure.
Okay, so if there's no more questions, then thank you everyone for joining us today. I hope
There is.
Oh, yeah.
From John Egan. Is the name of the API you discussed called Workflow Automation API or Data Platform API?
So there is two APIs. So the data platform on the workflow automation API. Yes, two different API, but working on the same idea. Okay, so thank you everyone. Thank you for joining. Late for a couple of people, I know. Difference. Yeah. Data is data, workflow is automation. The workflow would be to automate the data or task. You're welcome. Okay, thank you everyone again. If you have any question, please reach out. We can certainly answer questions within the next few days. With that, I'll probably stop the recording.
Yeah.
Stop recording. Do you want to stop recording?